Good evening. Thank you for coming to tonight's presentations. We are CodeCent. Tonight we'll be talking about version 0.21b. We are part of the Improving Student Monitoring application for the Douglas Honors College. So my name is Andrew Dickerson. I'm the team lead. Ben Garza is our tester. Brent Strong is the QA manager. John Wright is the database architect. And Kevin Jacobs is the software architect. Our advisor is Dr. John Ambick. As I'm sure you guys know, he's a professor, or an assistant professor in the computer science department. Our client is not here tonight. Her name is Christina Dennison, and she's a secretary at Douglas Honors College. Tonight we'll be going through a brief recap of our previous project, as well as our previous presentation, our previous iteration, our future iterations, our current iterations, some changes that happen in the user interface, our automated testing, QA testing, and then conclusion and question answer. So I'm going to turn it over to John now. He's going to go over the project recap.
So as discussed last time, Christina's current process for monitoring the students in the Douglas Honors College program, she uses 3 separate access databases. They contain a lot of repeated information between them, so it's difficult to navigate and manipulate students. And it's hard to report on previous year's data because every year is an actual separate set of those 3 databases. So every year has a whole new set of 3. So our product is going to be a C# desktop application. It'll use one central SQL database. The table design for these is based off of those 3 separate access databases that she currently has, so with some slight modifications to better suit us. So this eliminates that redundancy. Anytime you create a student, you don't have to enter it into 3, you just enter it into our program and it just take care of all that. It simplifies the year-to-year reporting. The university requires that she stores the information of students for up to 6 years. So instead of 18 access databases, we just have our one database that stores 6 years worth of students, and she can just select a filter that'll pull all the students for whatever year and then generate reports off it. And so it's flexible for future growth. She can add or remove classes in the program, and it also would be fairly simple to implement a client-server model. So these are the required features for our program. For our first iteration, we created the database and we developed a UI for viewing the students that are in the database, but couldn't actually modify or change it, insert new students. So this was taken care of in the second iteration. So the one we just completed, you can now create students, insert them, edit students. We also implemented a search feature to search through the students. So Andrew will now talk about the interface.
So our previous iteration had a completely different user interface. It was actually discovered during a resizing issue where we weren't able to resize the window, that we needed to make some changes to the user interface. Instead, what ended up happening was a complete redesign of the UI, kind of the last minute. So the old interface design was focused primarily on functionality. It looked a lot like a sketch. It was lacking styles, it just used basic borders, and there was very little consideration as far as the organization fields. We wanted just to ensure with our client that all the necessary fields were present and then the necessary options were there before we got into exactly where they would best appear. Our client as well didn't have a lot of discernment or opinion on where we should put all these fields, so a lot of this was left up to our team. So this is a picture of the first interface. It's actually not a bad looking programming. We ended up using the ribbon application. That's where you get the top ribbon, make it look like the other Windows 7 programs like Office. But you can see like the filters for the search are at the bottom left there. We felt like that wasn't a very good place for them because in order to select a student, you must first select a year, and that's the very bottom box. We thought you better suit it in the correct order of operations, if you will. In addition, you'll see there's tabs across the top to see different portions of the student's information. So while using GitHub for Mac OS X, if you don't know, I love using the Mac OS X things all the time. So I used this program called GitHub, which is our repository system. You'll actually see very similarities here to our new UI. What I liked about this is how simple it is, how there's quite a few features, but they're all kind of hidden, but not hidden to the point where they're not intuitive. So the reasoning behind our changes here was restructuring. While aesthetics we realize aren't the most important aspect, they are important because she will be viewing it quite often, as well as the organization needs to make sense very quickly, so there's not a lot of learning that needs to be done. So our current iteration looks like this. We've removed the Windows border around it, created our own setup of borders. That's where it kind of looks like a Mac application, as well as we removed the tab control across the top in favor of the expanders that can be pulled down. And you can have them all open and then use your scroll bar on them. We still have all the same functionality, but we were able to do it without using the standard file menu or edit, insert, all those menus. And instead just have your students backup reports and settings, which you'll see in the demonstration. In addition, those filters got moved up to the top, and they're all in the correct ordering now. As well as the save features, it's disabled, and we have a feedback button, which we'll talk about in a minute. So comparing the old and the new, so there's quite a few changes. We actually went after a sound here, and it was, again, developed a lot after that GitHub application we saw. So now Kevin will take us through an iteration demonstration.
So what I'm going to be showing you is basically the newest version of our program that we've done an acceptance test on with the client. Right now, it's populated with test data, and normally on our development machines we have more records just to be more realistic in our testing. But from a use case scenario, normally Christina would use this program to view students. So you see we have our whole student list here. You can click on any of them, and their most important information is right along the top bar. If she needs to know more or needs to change any aspect of their record, she can expand any of these and change any of their program features or assign them a different course grade, anything like that. So the modifications, like Andrew was mentioning, the save button is grayed out. And the reason for that is because there's been no modifications to the record yet. So if we change something, that's enabled. So she can save that, or if she tries to move to a different student, she's prompted to save those changes. So we'll go ahead and rank those. Again, from viewing students, we have the filtering, and we'll have each school year present in the list, so she can, because we're storing that 6 years of data, it's necessary to be able to filter year to year. And then sorting by class standing, you get your 4 class standing options, and then it just filters the student list to what's applicable. Similarly, program type, all pretty specific to the DHC, but that was a requirement that she would need to use a lot. And then our searching can be done by student ID, first name or last name, and it's all real time, so as soon as you start typing, the list is filtered down to whatever you're looking for, or like I said, student ID. And then the other iteration feature was creating a student. So we have our full student list. We'll click the new student button in the lower left-hand corner, and a new student record's pulled up and added to our list box on the left side. Hovering over the name, you see the little pencil icon to edit that. And we'll just create a pretty generic student object here. Save that, and then it's added and alphabetized back into the list of all the other students. Moving through some of the other tabs on the UI, the backup functionality is all contained in this canvas. And the backup and the reports are iteration 3 features, which should be coming in the next few weeks. But what we've envisioned is basically being able to create a backup as well as see previous backups in the lower half of the screen. And then reporting would take place here. Settings, basically, we have, right now it's a little bit bare, but we have the host name and basically path to the SQL server because she did want the possibility of expanding it to multiple workstations later on. And then our 4th iteration feature, the course changer, basically allows you to add multiple courses for future expandability. And all the actual C# logic for that is done and working. The problem so far has been dynamically populating these fields, either combo boxes or some other type of control at runtime to hold all that. So that's not due until iteration 4, but once we get a handle on that, it should be pretty simple to work out. And lastly, the feedback button here is for development versions that we install on Christina's computer. And basically, any thoughts or any bug report or anything that she would like changed, she can just type us a quick note here, hit save, and then it's logged locally with the date and time. as well as error logging to make sure that we're getting as much feedback as possible. So I'll cover testing now. And basically what we've done for testing from the UI perspective is a lot of manual testing just because of the difficulty of automating a lot of that. We do have automated tests for our student object and for the database controller class that we use. And we have done load testing on the database controller, even though that wasn't a specific requirement, just to make sure that our code was robust enough to be on a slow machine or somewhere facing a situation that we wouldn't exactly design it for. So automated unit and integration tests. Our tests are largely integration just because they call a lot of different functions within our program. Primarily white box, although we have done black box testing with the client. Brent will talk about that in a minute. We've also done positive and negative tests, so we're testing automated for the behavior and the requirements that we expect, but we also have tests for like a null student or a student created with all null fields just to make sure it won't crash our UI or things like that. So here's a screenshot of the Visual Studio test coverage extension. Basically, like I outlined, the student and the database controller are covered very well with automated tests. The presenter and the main window classes, somewhat less, but that's just due to the UI automation difficulties. And one of the reasons our tests are a little bit large is right now the student class has 60 different properties. And the reason for that is that every piece of their contact information, grades for every class, and that will be simplified with the dynamic being able to add courses because we're moving to a hash table to store grades. So it's just one grades object rather than a specific, like a string in the student class for each class or each course. And then for the UI testing, we do, instead of fully automating it, we have some partially automated tests where basically we call the UI functions programmatically and then present a tester with like a dialog box with yes or no options, and then like a criteria of what should be visible or what should be selected. So if at any time something didn't happen that was expected, they click no and the test fails, or they can click yes and it just guides through the test so we can make sure that the basics of the UI are covered every time. And then, like I said, the load testing wasn't strictly necessary, but it did highlight some inefficiencies, and we were able to improve on saving time and things like that for student records. So moving forward with the next two iterations for improving obviously we want to automate more of the UI testing. We've looked into a couple options for that, but just haven't had the time to work those out yet. And then since we have a scheduled installation next week with our client, obviously we're going to be getting a lot of feedback as far as if we have bugs. So we need to find those areas and then create and expand tests to make sure that those issues are resolved. So now Brent's going to go over our process and some more testing.
All right, so for this project, we went with the agile process, primarily because we like the flexibility and just the fact that we'd be having daily scrums to make sure we were all up to date and involved with the project, and also inform the individual responsibilities for each person. And this also ties into our regular client meetings to gather additional requirements if there are any feedback or just to verify requirements that we're meeting. Coding guidelines for the code structure with our project so far, we've stuck to what we established in our QA plan as far as just naming conventions and like error handling, commenting. We've done a good job there, and we will plan to use static analysis tools just to further enforce good style, clean, legible code, not only for us, but if this is a future project for another team, or if anyone else needs to work on this in the future, say if they plan to expand to that server client model, it wants to be easy for them to navigate. For bug tracking, We are currently using Jira for major bugs. We currently only have 5 logged right now. Most of our bugs have just been minor and have been resolved locally because we tend to program in a pure programming setting altogether. And when bugs arise, it's easier to just deal with them on the spot then and there. For version control, we are using GitHub. It is a distributed version control, which means we each have our own copy of the project in our own repository. And this helps because if detrimental code had been committed that would have a negative impact on the project, it would only be in one person's repository instead of affecting just a single one. So it's easier to handle errors such as that. And also, as far as major changes, such as our UI that we just went through this previous iteration, we can put that into a separate branch and go over that as a team and merge all our repositories together when it's all together. And like Kevin said, we recently just had our first client acceptance test. Our client was very pleased with the progress we've made. Overall, it met all of our requirements. We did, however, gain some valuable feedback as far as some of the functionality we need to include. I think there was an additional option she would like in the filtering, for filtering students, and there was a class that needed to change. And then this also ties into our feedback button, which will go hand in hand with our acceptance test, just as far as gathering feedback and making sure we're meeting requirements and handling any errors that come up. This is just a picture of our acceptance test form that we filled out. It's pretty straightforward. Basically, we all just sat down with her at the computer and gave her the latest version of our software and had her go through this list of tasks which were associated with the requirements we fulfilled this previous iteration, and then just wrote down some comments associated with each one, and then additional comments in a box. And now Ben will go through future iterations.
So for our third iteration features, we will be implementing a new student button from email, which will allow the user to parse students' information from an email into the correct fields in our application. We will also add the ability to back up the entire database to SQL and locally. And reporting will allow our client to pull statistical data from the database, for example, if they graduated and at what GPA. For our fourth iteration, it will add the ability to add a class or a program under the correct text field, and will generate a new column for that item in the database. And lastly, we'll polish the final product. In conclusion, for our project this far, there has been upwards of 3,500 lines of code, not including the custom controls. All of iterations 1 and 2 requirements and deadlines have been completed. Iteration 2 was accepted by the client. Installation of both database and application are scheduled to be done next week after at the client's site. With our most recent iteration complete, we estimate that 60% of the project is done. And our third and fourth iteration are on track to be completed within our scheduled deadlines. And delivery of our final product will be in early March.
Thank you for listening to our presentation. At this time, I'd like to open up for questions. Chris?
Yeah, what was your integration process? How did you integrate the changes each of you made into the main branch?
Well, since we're using Git, there really is no main branch specifically. Typically what happens is we'll all have different code in our repositories and we'll come together at a team meeting. Usually we'll create a new branch, say I'll pull Andrew's code, and then I'll merge his branch into mine. At that point I've got his code, and then just commit from there. Did you have, does that answer your question? Or?
Sort of. How do you determine which branch to get to the client then?
Primarily, well, when we started, we knew we were using distributed version control, and that would be an issue. So we kind of designated myself as the build master. So my branch is typically the most up to date, and then at release times we just tag it. So a tag is similar to a branch, but it stays in the same branch, so we just tag that as 1.0 or whatever. So at any point in time, we have that in, if nothing else, my repository, but then as soon as they update, they get a copy of that as well.
To add on to what Kevin said, and as Brand said, we generally do peer programming, so what will happen is we might have specific tasks that each one of us will accomplish on our own and put into our repository. So yeah, we're not editing the same program. Then when we all get together, we'll get all these changes in one specific version. And
how are the changes ported from one branch to the other?
pasty.com or
either direct copy paste into the actual CS file, or more typically just merging with Git. It sounds confusing, but it's actually worked out really well so far.
Now, have you already created your database in SQL. Have you ported all the old information from Access, or is that a requirement?
we have Excel databases where we pulled in the information from Access, and then we can import it, export it from Excel into our program, and that creates the database tables. But we haven't used the actual data from the client at this point. What we'll end up doing when we install next week is creating a new database, because there isn't one that exists at the moment. Creating a new SQL database, and then creating those tables with the scripts.
Do you see any possibility of running into compatibility errors between Access and SQL? As far as
we should, because currently we've been using the Access in Excel to create our own, to make sure that doesn't happen when we get to the client's computer. And we've set aside a large amount of time to install this. Once it's installed, it shouldn't need to be changed.
Just looking forward to the next iteration. What type of information are you going to parse out of that email? Is it a structured form of email, or is it just text, or how does that work?
John?
She actually has a web form actually out on the central website. They type the information into, and then they hit send, and it creates it into an email. So it will always be structured. Exactly.
Okay,
so it's easily
good.
parsable. Yeah, it's just a form that they fill out. It's not very
Can a user use a keystroke to get to your ribbon button? Things like a user used to be able to with menus.
You mean at the very top, those four
Right.
options? The idea behind the four options is they're rarely accessed, kind of want them out of the way. But yes, it is within the tab control. It's actually towards the very end of the tab control. So if, the answer is yes. In tab control, there's no access key to get to it quickly, but it does exist within just using tab. It's just a basic button that's just been, has a complete new style applied to it.
Okay, so you can't do like an Alt F to get to the file menu,
Correct.
and then
you cannot.
X to get to the exit.
Right, because it doesn't have the typical options that would be within the file, like open, things like that. Our program doesn't allow for those. We don't have any need for those
Okay.
options.
So when somebody's mouse dies, how do you navigate if your mouse dies?
To reporting.
Right, to navigate either to exit the program or to navigate around in the application between the different tabs and stuff.
Well, exit should be all F4, as always. Minimize, Control M, or I believe works. Maximize is the same. All of the exact. It's using Windows presentation.
All right, then how about
foundation.
getting in between the tabs?
It's just using the tab button. It's within the tab control ordering, so does that make sense? There's no quick way to jump to it. It's just if they're already selected on the ear button, or if they choose to select the button.
As far as shortcut keys,
Right.
are you talking about? Yeah.
Right.
We currently don't have that implemented, but I mean, it wouldn't be too hard.
Right, yeah. You need to make sure that users can get to things without a mouse, because mice sometimes do die.
Right, and we have it set up now, but I think we're looking for a shortcut
Okay.
to get to those options.
Cool.
All right.